Okay, so in this video, I'm going to introduce a solution of 2.NA Step 3, Question 3. Before I introduce a solution of this question, I should remind you that this question involves a huge amount of messy calculations that involves sort of high school analytic geometry, which is sort of thing you do different kind of simple algebra in a Cartesian system. So maybe you can just choose the part that you want to the part maybe what I mean is maybe you should just choose a core idea of this video to have a glimpse on it, and for the other messy calculations maybe you can just skip it. But if you want to try this question for yourself, maybe those messy calculations I listed is a good helper of if you want to check whether your answer is correct. Okay, so the point P with coordinates a cosine theta and b sine theta lies on the ellipse. So okay, the first time you see the word ellipse, you should have the picture of the ellipse in your mind, which is just okay. I'm sorry, which is just if you have Cartesian system, then your ellipse should look like that. It's just an ellipse. Okay. Maybe it's not very standard, but I'm just trying to illustrate what I'm going to say. So this is an ellipse. X squared over a squared plus y squared over b squared equals 1. This is our ellipse. And the point S minus EA0, where b squared is equal to a squared times the bracket of 1 minus e squared. I should remind you that this equality, we will use it considerably during the procedure of solving this question. So the point S, the focus of a ellipse is just the point here, this point and this point. They are the focus of a ellipse. So for example, if I so in this ellipse, this coordinate is the coordinate of this point is a0, and for this is b0, and for this one is negative a0, this one is negative b0. And the focus, if I name this a and name this b, and I should remind you that the absolute value of I should remind you that the distance of this line plus the distance of this line is equal to 2a. So this is just the meaning of the word focus of a ellipse. So those are two focuses, and n is the foot of the perpendicular from the original, the tangent to the ellipse at P. So okay, for example, we have a point P right here, and we have a tangent right here. So I think what the question means is that if we have, this is the point O, and our N should be right here. If we connect the point O and point N, we shall have a right angle right here. this is point P, and this is the point N. And then the lines S, okay, so this point is one of the focuses, which is S. This point is S. SP and ON intersects at T. Okay, so SP and ON intersect at this point T. And the first question is asking us to show that the y coordinate of T is the following form. So let's get into it. The y coordinate of T. So the first time I see this, I'm just thinking that if I work out the equations for PS and ON, it will be easy for us to find the point T by combining those two linear equations together. So let's get into it. Let's find ON first. To find ON, we should find the tangent of this tangent. So we should find the gradient of this tangent. I'm sorry. So let's just to take the first derivative of this ellipse, which gives us 2x over a squared plus 2y over b squared dy times dy by dx is equal to 0, which gives us dy by dx is equal to negative b squared over a squared times x over y times x over y. Okay, and the gradient of this tangent will be just equal to, so dy by dx at p is just negative b squared over a squared times, so the x coordinates of p is just a cosine theta and y is just b sine theta. We should just substitute those values in. So this is a cosine theta and this is b sine theta, which gives us negative b cosine theta over a sine theta. This is a gradient of this tangent MP. So which is a gradient of tangent MP. So because ON is perpendicular to MP, so immediately we will have the formula for the line ON, which is just a sine theta over b sine theta x, and c is equal to 0 because it passes origin. And this is the formula for ON. So next goal, we want to find the formula for PS, which is not very difficult because we have both coordinates of S and P. So what we want to do is just to combine the equations after substituting what we have. So let's see. So point P has coordinates a cosine theta and b sine theta. So by substituting it, we will have m times a cosine theta plus c is equal to, let's see, b sine theta. And this is the relation from P, and the relation from S is just m times negative EA plus C equals 0. And this is from S because S has coordinates of negative EA 0. Okay, so nextly, next thing we want to do is to solve this simultaneous equations. We solve it by first adding, by first subtracting s by p, which gives us m a cosine theta plus ea equals b sine theta, and it gives us m for ps, equals b sine theta over a sine theta plus ea. Okay, and then since we already have the m for ps, which is b, I'd like to write it down because it will be clear for us to solve this question. Okay, b sine theta, a cosine theta plus ea, a cosine theta plus ea. And from the relation we get from s, we can just substitute the value of m we already have to evaluate the value of c. So here's what we have: b sine theta over a cosine theta plus ea times negative ea plus c is equal to 0, which gives us that c is equal to let me see, b e sine theta over cosine theta plus e. So this is our c, and this is our s. So this is our c, and this is our m. So we can construct the formula for ps, which is just b sine theta over a cosine theta plus ea x plus b e sine theta over cosine theta plus e. So next thing we want to do is just to combine this line with this line, and to evaluate the y coordinates of t, because t is the intersection of these two lines. So we want to substitute the value of x, which equals, let me see, this equals b cosine theta over a sine theta times y. And from this, we can substitute this into this, and we will have y equals b sine theta over a cosine theta plus ea times b cosine theta over a sine theta times y plus b sine theta, eb sine theta over cosine theta plus e. And this from here we can see the signs are cancelled, and we will have y equals b squared over a squared plus multiplied by cosine theta over e plus cosine theta times y plus EB sine theta plus over E plus cosine theta. And again, from the relation we have here, b squared is equal to a squared times 1 minus e squared. So we will have our equation as y times 1 minus e plus cosine theta over cosine theta 1 minus e squared is equal to EB sine theta over E plus cosine theta. So from here we can multiply both left hand side and right hand side by the factor of E plus cosine theta, which eliminates us several terms. So y is equal to y times E cosine theta minus cosine theta plus E squared cosine theta is equal to EB sine theta. And the answer is clear that y is equal to B sine theta over 1 plus E cosine theta. This is the answer of our first sub-question. And the next question is asking us to show that point T lies on the circle with center S and radius A. So T is here and S is here. So T lies on the circle that is created by S. So in order to achieve this, the distance between T and S must be A in order to the condition provided by the question to be true. So we just want to calculate. So for the final question, we just want to calculate the value of abstract value of Ts. In order to do this, we must have the x coordinates of T as well. But I'm not willing to do that because it is super messy and it is but the idea and the procedure is super easy. We can just we just need to substitute y equals a sine theta over b cosine theta times x into the line yps. Then we can get x is just equal to a cosine theta 1 minus e squared over 1 plus e cosine theta. So this is our x value for the point T. Then the final thing we need to do is just to evaluate Ts. So Ts, so we can see that the point T is xt yt, and the point S is negative EA 0, and this is xt, this is yt, xt and yt. So the modulus of Ts is literally equal to yt is literally equal to the square root of yt squared plus so this is xt, so plus xt plus ea squared. This is the value of ts, and which equals yt is just, I'm sorry, I just not willing to do that anymore. Yt squared is equal to b squared sine squared theta over 1 plus e cosine theta squared plus this is super messy, a cosine theta times 1 minus e squared over 1 plus e cosine theta plus e a squared, which equals from here I want you guys to know that our goal is to have this modulus of ts to be a. So I think we should just need to extract a from this messy square root term. So we extract a and wish this messy square root to be 1. Okay, so if we extract a, this b squared will be divided by a squared, which is just 1 minus e squared. So which gives us 1 minus e squared times sine squared is just 1 minus cosine squared over, sorry, this is not very clear, 1 plus e cosine theta squared plus, so for the following term all the a's are extracted, and by multiplying 1 plus e times cosine theta on the term e on both numerator and denominator, we will end up with 1 plus e cosine theta squared. So never forget to add the square here. So cosine theta 1 minus e squared plus e squared cosine theta. And then we can just extract this 1 plus e cosine theta squared over 1 right here, and in the bracket we have 1 minus e squared 1 minus e squared minus cosine theta squared plus e squared cosine theta squared plus so cosine theta minus e squared cosine theta, so e squared terms are cancelled, so we have e plus cosine theta squared, so which equals a times so this is e squared plus 2e cosine theta plus cosine squared theta. So by cancelling all the terms, we will end up with just 1. So sorry. So this and this are cancelled, and this are cancelled. So we just have 1 plus 2e plus 1 plus 2e cosine theta plus e squared cosine squared theta multiplied by 1 plus e cosine squared of cosine, 1 plus e cosine theta over 1. And this term is just 1 plus e cosine theta squared, so which just gives us a, and this is the goal we want to meet. Okay, and this is briefly the whole solution of this question.